When upgrading a main entrance service and dealing with an existing subpanel fed by old-style service entrance cable, there are crucial code considerations to keep in mind. The short answer is no. You cannot simply land the existing feeder on a new breaker without addressing the cable itself. The old-style service entrance cable, while potentially acceptable at the time of its original installation, does not meet current standards for use as a feeder to a subpanel in many jurisdictions. Electrical codes, such as the National Electrical Code, or NEC, outline specific requirements for wiring methods based on safety and performance standards. These codes are regularly updated to incorporate new technologies, address emerging safety concerns, and improve the overall reliability of electrical systems. Firstly, it's essential to understand the specific limitations of old-style service entrance cable. This type of cable typically lacks a dedicated grounding conductor and may not have the same level of insulation and protection as modern feeder cables. Secondly, the NEC mandates the use of approved wiring methods for feeders supplying subpanels. Feeders carry the main electrical load from the service equipment to the subpanel, and they must be capable of safely handling the current, providing adequate grounding, and resisting physical damage. Thirdly, replacing the old-style service entrance cable with an approved type of feeder cable ensures compliance with current codes and enhances the safety and reliability of the electrical system. Common types of approved feeder cables include THHN, THWN, or XHHW conductors installed in conduit, or Type UF cable for underground installations. The specific type of cable required will depend on the installation environment, the ampacity requirements, and any local code amendments. When selecting a replacement feeder cable, it's important to consider several factors. One factor is the ampacity of the cable. The ampacity must be sufficient to carry the load served by the subpanel, taking into account any future expansion or increased demand. Another factor is the voltage drop. The voltage drop should be minimized to ensure that equipment connected to the subpanel receives adequate voltage. And finally, the environmental conditions such as moisture, temperature, and exposure to sunlight must be considered. In addition to replacing the cable, it's also important to ensure that the subpanel itself is properly sized and rated for the load it serves. The subpanel should have sufficient overcurrent protection, such as circuit breakers, to protect the circuits connected to it. It should also be properly grounded to provide a safe path for fault current. When making the connection to the new breaker, ensure it is correctly sized for the feeder cable and the load it will carry. Use appropriate lugs and connectors to establish secure and reliable terminations. Tighten all connections to the manufacturer's specifications to prevent overheating and arcing. A proper grounding system is crucial for safety and proper operation of the electrical system. The grounding system should include a grounding electrode conductor connected to a grounding electrode, such as a ground rod or water pipe. The grounding electrode conductor should be sized according to the NEC and securely connected to the service equipment and the subpanel. All metal enclosures, such as the service panel, subpanel, and conduit, should be bonded together to create a continuous ground path. This helps to minimize the risk of electric shock and ensures that fault current can flow safely back to the source. During the upgrade, carefully inspect the existing wiring and equipment for any signs of damage or deterioration. Replace any damaged or worn components to ensure the reliability and safety of the electrical system. Pay close attention to the condition of the service entrance conductors, the meter socket, and the grounding system. If you encounter any unexpected issues or have questions about the code requirements, consult with a qualified electrical inspector or engineer. They can provide guidance and ensure that the upgrade is performed in accordance with all applicable codes and regulations. Here is a step-by-step approach to upgrading the service entrance and replacing the old service entrance cable. Firstly, plan the upgrade. This includes determining the load requirements of the subpanel, selecting the appropriate type and size of feeder cable, and obtaining any necessary permits. Secondly, disconnect the power. Before starting any electrical work, disconnect the power to the service entrance and the subpanel. This can be done by turning off the main breaker at the service panel. Thirdly, remove the old cable. Carefully remove the old-style service entrance cable from the service panel and the subpanel. Take note of how the cable is routed and secured. Fourthly, install the new cable. Install the new feeder cable following the routing and securing methods used for the old cable. Ensure that the cable is properly supported and protected from physical damage. Fifthly, make the connections. Connect the new feeder cable to the service panel and the subpanel. Use appropriate lugs and connectors to establish secure and reliable terminations. Sixthly, test the installation. After completing the installation, test the system to ensure that it is working properly. Use a multimeter to verify the voltage, current, and grounding. Also, check for any loose connections or other potential problems. When selecting a new breaker for the feeder, consider the following factors. Firstly, the ampacity rating. The breaker should have an ampacity rating that is equal to or greater than the ampacity of the feeder cable. Secondly, the interrupting capacity. The breaker should have an interrupting capacity that is sufficient to handle the available fault current at the service entrance. Thirdly, the type of breaker. The breaker should be of the correct type for the application, such as a standard thermal magnetic breaker or a ground fault circuit interrupter. When making connections to the breaker, follow the manufacturer's instructions carefully. Use the correct size and type of wire connectors, and tighten the connections to the specified torque. Improper connections can lead to overheating, arcing, and even fires. A proper grounding system is essential for safety and proper operation of the electrical system. The grounding system should include a grounding electrode conductor connected to a grounding electrode, such as a ground rod or water pipe. The grounding electrode conductor should be sized according to the National Electrical Code, or NEC, and securely connected to the service equipment and the subpanel. All metal enclosures, such as the service panel, subpanel, and conduit, should be bonded together to create a continuous ground path. This helps to minimize the risk of electric shock and ensures that fault current can flow safely back to the source. Here are some additional safety tips to keep in mind when working with electrical systems. Firstly, always disconnect the power before working on any electrical equipment. Secondly, use insulated tools to prevent electric shock. Thirdly, wear appropriate personal protective equipment, such as safety glasses and gloves. Fourthly, never work on electrical equipment when you are wet or standing in water. Fifthly, if you are not comfortable working with electrical systems, hire a qualified electrician. When upgrading a service entrance, it's also important to consider the impact on other electrical systems in the building. For example, if you are increasing the size of the service entrance, you may also need to upgrade the grounding system and the overcurrent protection devices. In some cases, you may also need to upgrade the wiring in other parts of the building to accommodate the increased load. Before starting any work, it's a good idea to have a qualified electrician perform a load calculation to determine the total electrical load of the building. This will help you to determine the appropriate size for the service entrance and the other electrical components. In addition to the technical aspects of the upgrade, it's also important to consider the aesthetic aspects. The service entrance should be installed in a neat and professional manner, and all wiring should be properly concealed. The service panel should be labeled clearly, and all circuits should be identified. When the project is complete, ensure that all work is inspected by a qualified electrical inspector. The inspector will verify that the installation meets all applicable codes and regulations, and they will issue a certificate of compliance. This certificate is important for insurance purposes and may also be required for resale of the property. In summary, upgrading a service entrance and replacing old-style service entrance cable requires careful planning, attention to detail, and compliance with all applicable codes and regulations. By following these guidelines, you can ensure that the upgrade is performed safely and effectively, and that the electrical system is reliable and safe for years to come. Always consult with a qualified electrician or electrical engineer if you have any questions or concerns. Working with electricity can be dangerous, and it's always best to err on the side of caution. Take your time, follow the instructions carefully, and never hesitate to ask for help when you need it. Electrical safety is paramount. Remember, the goal is to provide a safe and reliable electrical system for the building and its occupants. By taking the necessary precautions and following best practices, you can achieve this goal and ensure the long-term safety and performance of the electrical system. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical installations in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for electricians, contractors, and inspectors to be familiar with the NEC and to follow its requirements when performing electrical work. The NEC is not a law, but it is often adopted by state and local jurisdictions as part of their building codes. This means that compliance with the NEC is mandatory in those jurisdictions. The NEC is constantly evolving to keep pace with new technologies and safety concerns. It is important to stay up to date with the latest edition of the NEC and to understand any amendments that have been adopted by your local jurisdiction. In addition to the NEC, there may be other applicable codes and regulations that you need to follow. These may include local building codes, fire codes, and energy codes. It is your responsibility to be aware of all applicable codes and regulations and to ensure that your work complies with them.